as a mountaineer climbs a mountain because it is there, so a good mathematics student studies new material because it is there. What's up, guys? Welcome back to my channel and welcome to my YouTube channel. With this quote in our mind, we can start a new chapter, that is integrals, chapter 7 from class 12 Maths textbook part 2. Differential calculus is centered on the concept of the derivative. The original motivation for the derivative was the problem of defining tangent lines to the graphs of functions and calculating the slope of such lines. Integral calculus is motivated by the problem of defining and calculating the area of region bounded by the graph of the functions. If a function f is differentiable in an interval I, that is, its derivative f inverse, exists at each point of I, then a natural question arises that given f of x at each point of I, can we determine the function? The function that could possibly have given a function as a derivative are called antiderivatives or primitive of the function. Further, the formula that gives all these antiderivatives is called the indefinite integral of the function, and such process of finding an antiderivative is called integration. Such type of problems arise in many practical situations. For instance, if we know the instantaneous velocity of a position of the object at any instant, there are several such practical and theoretical situations where the process of integration is involved. The element of integral calculus arises out of efforts in solving the problems of the following types. That is, the problem of finding a function whenever its derivative is given. And the second one is the problem of finding the area bounded by the graph of a function under certain conditions. These two problems lead to the two forms of integrals, for example, indefinite and definite integrals, which together constitute the integral calculus. There is a connection known as the fundamental theorem of calculus between indefinite integral and definite integral, which makes the definite integral as a practical tool for science and engineering. The definite integral is also used to solve many interesting problems from various disciplines like economics, finance, and probability. In this chapter, we shall confine ourselves to study of indefinite and definite integrals and their elementary properties, including some techniques of integration. So before starting this chapter, I have to share with you maybe like 21 equations or formulas that are used in this chapter to at least solve one question. Without the knowledge of these equations or formulas, you won't be able to solve at least one of the questions, example questions or exercise questions that is given in the textbook. So I'll just share screen my whiteboard. Yes, so the first one is integral of x raised to n dx is equal to x raised to n plus 1 by n plus 1 plus c. The second one is integral of dx is equal to x plus c. Third one, integral of cos dx is equal to sin x plus c. The fourth one is integral of sin x dx. Okay, 1 minute. Here, this cos, actually it should be cos x dx. Okay, I forgot about it. Here, if it's sin x dx, then this also will be cos x dx. So sin x dx is equal to minus cos x plus c. The fifth one is integral of sec square x dx is equal to tan x plus c. Sixth one is integral of cosec square x dx is equal to cot x plus c. The seventh one is integral of sec x tan x dx is equal to sec x plus c. Eighth one is integral of cosec x cot x dx is equal to minus cosec x plus c. Ninth one is integral of dx by root of 1 minus x square is equal to sine inverse x plus c. 10th one is integral of 1 by root of 1 minus x square dx is equal to minus cos inverse x plus c. 11th one, integral of 1 by 1 plus x square dx is equal to tan inverse x plus c. And the 12th one is integral of 1 by 1 plus x square dx is equal to minus cot inverse x plus c. 13th one, integral of 1 by x into root of x square minus 1 dx is equal to sec inverse x plus c. 14th one is integral of 1 by x into root of x square minus 1 dx is equal to minus cosec inverse x plus c. 15th one is integral of e raised to x dx is equal to e raised to x plus c. 16th one is integral of 1 by x dx is equal to log modulus of x plus c. 17th one, integral of a raised to x dx is equal to ax by log a plus c. 18th one, integral of tan x dx is equal to log modulus of sec x plus c. 19th one, integral of cot x dx is equal to log modulus of sin x plus c. 20th one, integral of sec x dx is equal to log modulus of sec x plus tan x plus c. The 21st one is integral of cosec x dx, integral of cosec x dx, cosec x dx is equal to log modulus of cosec x minus cot x plus c. So these are the 21 formulas or equations that are used in this chapter to solve each example questions or either exercise questions. So the first one is integral of x raised to n dx is equal to x raised to n plus 1 by n plus 1 plus c. Second one is integral of dx is equal to x plus c. Third one, integral of cos x dx is equal to sin x plus c. Fourth, integral of sin x dx is equal to minus cos x plus c. Fifth, integral of sec x square dx is equal to tan x plus c. Sixth, integral of cosec square x dx is equal to cot x plus c. Seventh, integral of sec x tan x dx is equal to sec x plus c. Eighth, integral of cosec x cot x dx is equal to minus cosec x plus c. Ninth, integral of dx by root of 1 minus x square is equal to sin inverse x plus c. 10th, integral of 1 by root of 1 minus x square dx is equal to minus cos inverse x plus c. 11th, integral of 1 by 1 plus x square dx is equal to tan inverse x plus c. 12th one, integral of 1 by 1 plus x square dx is equal to minus cot inverse x plus c. 13th, integral of 1 by x into root of x square minus 1 dx is equal to sec inverse x plus c. 14th, integral of 1 by x into root of x square minus 1 dx is equal to minus cosec inverse x plus c. 15th, integral of e raised to x dx is equal to e raised to x plus c. 16th, integral of 1 by x dx is equal to log modulus of x plus c. 17th, integral of a raised to x dx is equal to a raised to x by log a plus c. 18th, integral of tan x dx is equal to log modulus of x sec x plus c. 19th, integral of cot x dx is equal to log modulus of sin x plus c. 20th, integral of sec x dx is equal to log modulus of sec x plus tan x plus c. 21st, integral of cosec x dx is equal to log modulus of cosec x minus cot x plus c. So that's all for today's video. Thank you.